Welcome to EduMoon tutorials. I'm Sravya. I'm your instructor for M2. In this video, we'll be discussing the Gauss elimination method, LU factorization method, and Gauss seidal method. Gauss elimination method. Gauss elimination method is a direct method for solving system of equations. Let's look into this. Consider system of equations which contains n unknowns and m number of equations. We'll be writing in the matrix form Ax equal to B. Now, let's consider augmented matrix C equal to A colon B. We'll be reducing the C matrix into echelon form using some row transformations. Let's look into this example to understand this. Solve the following system of equations by Gauss elimination method. First, let's consider augmented matrix C equal to A colon B, where A is a coefficient matrix and B is a constant matrix. Now, in order to convert this into echelon form, we need to convert these elements into 0. So first, let's convert these elements into 0. So, row 2 tends to row 2 minus 2 row 1, and row 3 tends to row 3 minus row 1. Now, we are left with these elements. Let's convert this element into 0. So, we'll convert row 3 into row 3 plus row 1. Row 3 converts into row 3 plus row 2, not row 1. Now, we'll be getting some system of linear equations. Let's solve these equations. First, minus 9z equal to minus 9, minus 2y minus 10z equal to minus 14, and x plus 3y plus 2z equal to 5. These are equations. Let's solve one by one. So, we'll be getting z equal to 1 from this first equation. Let's substitute this z value in the second equation. Y equal to 2. Let's substitute this value into equation number 3. X equal to minus 3. So, the solution for this system of equation is x equal to minus 3, y equal to 2, and z equal to 1. We can verify these values by substituting in the given equations. If the value satisfies the equation, then our solution is a correct solution. Gauss seidal iteration method. It is basically an indirect method for solving system of equations. Let's look into this example. Solve these given equations using Gauss seidal iteration method. First, let's rearrange these given equations as follows. Here, we need to find the variable values x by z from each of these equations. Since we found, let's take x not equal to, y not equal to, z not equal to 0. First, let's find first iteration variable values. For the first iteration, we'll be substituting the y and z values in this equation 1. For y1, let's substitute x1 and z0 in this equation. For z1, let's substitute x1 and y1 in this equation 1. Since we found x1, y1 and z1 values, let's do second iteration. We'll find the variable x2, y2 and z2 values similarly as x1, y1 and z1. For x2, let's substitute y1 and z1 in the equation 1. For y2, let's substitute x1 and x2 and z1 values in the equation 1. For z2, we'll substitute x2 and y2 in the equation 1. We'll do these iterations until we find that the last iteration and the previous iteration variable values are partially equal. Let's compare first iteration and second iteration variable values. Here, x1 equal to 0.85 and x2 equal to 1.0023. These are not partially equal. For y1, minus 1.0275 and minus 0.99 are partially equal. And for Z1, the values are partially equal. But in case of x1 and x2, the values are not partially equal. So we need to do another iteration value. Let's find third iteration now. Third iteration. Let's replace y2 and z2 in the first equation. Similarly for y3, we'll substitute z2 and x3 values in first equation. Similarly for Z3, let's substitute y3 and x3 values in the first equation. Since we found third iteration values, let's compare second iteration and third iteration to see whether they are partially same or not. Here, in second iteration, x2 equal to 1.0023 and x3 equal to 0.999. These two values are partially same. For y2, minus 0.99, and similarly for y3 equal to minus 1. These both values are partially same. For z3 equal to 1 and z2 equal to 0.9925. These values are also partially equal. So we can conclude the second iteration and third iteration variable values are partially same. So we'll be taking our variable values as the last iteration values. So x equal to 0.99 is nearly equal to 1. So let's take x equal to 1 and y equal to minus 1 and z equal to 1. This is the set of solution for the given equations. LU factorization method or decomposition method. First, let's consider system of equations. These are the three equations. Let's take A equal to LU, where L is a lower triangular matrix, where diagonal elements are equal to 1. U is an upper triangular matrix. First, since A equal to LU, we'll be multiplying these two matrices and we'll be finding this L1, L2, L3 values and U1 to U6 values using this A equal to LU. Now, since Ax equal to B, we'll be replacing A with Lu, then we'll be getting Lux equal to B. We know L and U values, so let's take Ux equal to Y. U is a matrix of order 3 by 3 and X is a matrix of order 3 by 1, that is. So if U and X are multiplied, we'll be getting a matrix of order 3 by 1. So y equal to y1, y2, y3 of order 3 by 1. Let's assume this. Now, since ux equal to y, then ly equal to b. Since we know L and B values, let's find y from this. Now, let's substitute y in this ux equal to y. We know u value and y value. So, we'll be finding x through this method. Solve the equations by LU decomposition or factorization method. Our given equations are, first, let's take LU equal to A, where L is a lower triangular matrix and U is a upper triangular matrix as discussed before. We'll be multiplying the first row with first column. We'll get U1. Now first row with second column. First row with third column. If you have any doubt regarding multiplication of matrices, please look into previous videos to get clarity about that. Now let's multiply the second row with first column. Now second row with second column. Now second row with third column. Now third row with first column. Third row with second column. Third row with third column. Let's equate these two matrices and find these variable values. First, u1 equal to 1, u2 equal to 2, u3 equal to 3. Now, L1 u1 equal to 2, L1 u2 plus u4 equal to 3. Let's substitute L1 and u2 values. Equal to -1. Now L1 u3 plus u5 equal to 4. So L1 equal to 2 and u3 equal to 3. u5 equal to -2. Now L2 u1 equal to 3. L2 u2 plus L3 u4 equal to 4. L3 equal to 2. Now last L2 u3 plus L3 u5 plus u6 equal to 1. u6 equal to -4. Let's substitute these variable values in L and U matrix. We'll be getting L as equal to Since Ax equal to b, Lux equal to b, let's take Qx equal to y. So Ly equal to b. Since we know L and B values, let's find y value. Y equal to b equal to 14, 20 and 14. Let's multiply these two matrices. We'll be equating this with this matrix. Let's find y1, y2, y3 values. y1 equal to 14. y2 equal to -8. Equal to -12. We got y matrix as y equal to 14, -8 and -12 is a matrix of order 3 by 1. Since we found y value, let's find x value. We took ux equal to y. Here we know the u value and y value. Let's find the x value. Let's multiply these two matrices. Let's equate. We're getting x equal to 1, x equal to 1, 3, which is a matrix of order 3 by 1. X equal to 1, y equal to 2 and z equal to 3 is the solution set for these given equations. Let's discuss eigenvalues and eigenvectors in our next video.